Hi all, today we're doing pre-calculus lesson 4.7, the law of sines and the law of cosines, learning objectives, solve oblique triangles using the law of sines or the law of cosines, find areas of oblique triangles. Let's start with the law of sines. The law of sines says that if we have an oblique triangle with angles capital A, capital B, capital C, and sides small a, small b, and small c, then we have sine A over A equals sine B over B equals sine C over C. We use the law of sines in the following cases: when we have a triangle with angle, angle, and a non-included side, angle, side, angle, and side, side, and a non-included angle. Now for the law of cosines, if we have an oblique triangle, then a square, which is the side a square, equals b square plus c square minus 2bc cosine a. B square equals a square plus c square minus 2ac cosine b, and c square equals a square plus b square minus 2ab cosine c. We use this law when we have a triangle with three known sides or side, angle, side. So two sides and an included angle. Let's do some exercises. Solve each triangle round side lengths to the nearest tenth and angle measures to the nearest degree. Exercise 1, we have triangle ABC with three known sides. We don't have any of the angles, so this is a case of SSS, which we're going to use the law of cosines to do this. Let's say we want to start with angle A. So we would say A squared equals b squared plus c squared minus 2 bc cosine A. A squared is 20 squared equals b squared 12 squared plus c squared 28 squared minus 2 times 12 times 28 cosine A. Everything is known except the cosine A. So 400 equals 144 plus 784 minus 672 cosine A. Bring this to this side to make it positive. Equals 144 plus 784 minus 400. So 672 cosine A equals 528, or cosine A equals 528 divided by 672. Now to find angle A, we would use the inverse cosine. Cosine minus 1, 528 over 672. That will give us 38 degrees. Now pause the video to make sure you understand what we're doing here. I'm going to write 38 here. Next to angle A, and erase everything else. Now that we know angle A, we can now use the law of sines. So we can say sine A over A equals sine B over B. or sine B equals 12, which is B, sine 38, which we found in the previously, divided by 20. To find angle B, we use the inverse sine function. 12 sine 38 degrees over 20, that will give us 22 degrees. So now I'm going to write 22 here for angle B. All we have to do now is find angle C. We know that the sum of all angles in a triangle is 180, so C equals 180 minus A plus B. 180 minus A was 38 plus 22 for B. C equals 120 degrees. So we were able to find all angles of a triangle. So let's look at the second exercise. We have side, angle, side, which means we're going to use the law of cosines first. So we're going to start by finding this side first, which is B. So B squared equals A squared plus C squared minus 2AC cosine B. All of these are known. You just need to find B. B squared equals A squared, which is 100, that's 10 squared, plus C squared, which is 64, minus 2 times A times C, that's 80 times 2 is 160, cosine 100. Okay, which means B equals square root of 164 minus 160 cosine 100. That will give us 13.84. Now the next step would be to find either angle A or angle C. To do that, we're going to use the law of sines. So we can say sine B over B equals sine A over A. We have A, we have B, we have sine B, we can find sine A. Sine A equals A times sine B, then sine 100 over 13.84. A equals sine minus 1, then sine 100 over 13.84. That will give us 45 degrees. So now this angle A is 45. To find angle C, C equals 180 minus the sum of A and B, which is 100 plus 45. So C equals 35, and that's it. Now we have all angles and all sides. Pause the video to make sure you understand what we did here. Let's look at this last example. In this case, we have angle, angle, and a non-included side, AAS. So we're going to use the law of sines here. First of all, let's find this angle because we have two angles. It's easy to find the third angle. C equals 180 minus 45 plus 30 equals 105. So we have all three angles now. Now let's find sides B and C. Let's start with side B. We can say here sine A over A equals sine B over B, which means side B equals A sine B over sine A. B equals then sine B sine 45 over sine A sine 30 equals 14.1 using the calculator. Now let's find sine or side C. Same thing. Sine A over A equals sine C over C. That means C equals A sine C over sine A equals then sine 105 over sine 30. C equals 19.3. And that's it. So we were able to find all three sides and all three angles. Please pause the video to look at what we did and try to understand it. For our last exercise, I'm going to leave this for you. We have two angles and a side, and we need to find the missing angle and the other two sides. So write in the comments, after watching this video, write in the comments and tell me what type of triangle we have here. Is it AAS or ASA or SAS? Whatever. Leave a comment and try to do this yourself. And let's wrap this video. Today we looked at the law of sines and law of cosines. Each law can be applied in certain situations depending on what we know from a triangle, from an oblique triangle. And by the way, an oblique triangle is a triangle that doesn't have a right angle. So none of the angles is 90 degrees. I hope you enjoyed the video. Please subscribe, like, and leave some comments. Any suggestions for improvement so that we can do better next time. And thank you very much.